In today's class, we are going to look at concept of electric charge. The word electric is gotten from a Greek word called electron, which means amber. Electric is gotten from a Greek word, electron, which means amber. That is why when amber is rubbed, with wool, when amber is rubbed with wool, it attracts other materials. It attracts other materials. Let's look at charge. Charge is the physical property. Charge is the physical property of matter. The physical property of matter, which causes matter, to experience, an electric force. Note also that charge can also be described as what makes objects attract or repel each other electrically. What makes objects attract or repel each other electrically. Remember, we are talking about electrically here because we are talking about charges. Charges in motion gives rise to electricity. We are aware of that. Let's go ahead and look at four basic elementary particles. Four basic elementary particles. Now, the first one is what we know as electron. Now, this electron is discovered. Electron is discovered by J.J. Thomson. Electron is discovered by J.J. Thomson. And of course, you are aware that electron is always negatively charged. Always what? Negatively charged. So let's look at the second one. We have what we call the up quarks. The up quarks. And this up quark has a value of positive 2/3 elementary charge. We also have what we call the down quarks. The down quarks. The down quarks have a value of negative 1/3 elementary charge. We have the last but not the least, the one we know as the neutrino. The neutrino has no charge. In fact, it operates with the speed of light. There is a point for you to note. This is very important. Pay attention here. When we have two up quarks, and one down quark, we call it the proton. That is to say that proton is made up of what? Two up quarks and one down quark. And it is discovered by Ernest Rutherford. Ernest what? Rutherford. Ernest Rutherford discovered proton. Let's look at this also. When we have two down quarks, and one up quark, we have what we call the neutron. We have what we call the neutron. I hope I'm communicating. And this neutron is discovered by James Chadwick. By James Chadwick. Now, I would love us to play with this a little. I'm going to give us a small exercise that has to do with these up quarks and down quarks and see how we can play with it. Okay, let's look at this. Show that proton has positive elementary charge. Show that proton has positive elementary charge. So how do we go about this? Then you recall that proton has two up quarks and one down quark. Now let's play with that and see. So proton has two up quark. So the up quarks are positive 2/3 elementary charge. Then plus one down quark, negative 1/3 elementary charge. Let's resolve this. 2 multiplied by 2 will give you 4. So we have positive 4 elementary charge divided by 3. Positive, negative will give you negative. So we have here negative 1/3 elementary charge. So let's go ahead and resolve this. We take our LCM. So which is 3. 3 goes into 3 will give you 1. 1 multiplied by positive 4 elementary charge. We have positive 4 elementary charge. Then we have our negative sign here. We reflect it there. Put a negative sign there first. Then 3 goes into 3 will give you 1. 1 multiplied by 1 elementary charge. You will have it as what? 1 elementary charge. Let's go ahead. Then here, positive 4 elementary charge minus 1 elementary charge. It will simply give us positive 3 elementary charge, then divided by 3. So 3 we cancel 3. Then we have positive elementary charge. So you see, we have been able to show that proton has 1 positive elementary charge. I hope I'm communicating. That's wonderful. Okay, also, let also show that neutron has zero charge, otherwise neutral charge. Show that neutron has zero charge or is neutral. Is neutral. Now, the same way we did for the previous, let's also do that here. Remember that neutron has two down quarks and one up quark. Okay, let's look at that. One up quark. That means we have positive 2/3 elementary charge. Then, and two down quarks. And two down quarks is what? Negative 2 into 1/3 elementary charge. So let's resolve that. So we have 2/3 elementary charge minus negative 2, that is 2 times 1 will give you 2. So we have 2 elementary charge divided by 3. So you see here, this is positive 2 elementary charge over 3 minus 2 elementary charge divided by 3. So you see, they are going to cancel out. So this will cancel this. Therefore, you have what? Zero charge or neutral charge. That is why our neutron is always neutral. I hope that is simple now for you and it's clear. So this is the way to prove that the neutron has what? Neutral charge. That's wonderful. Without wasting time, let's take a look at four basic forces. Four basic forces. Four basic forces. The first one is gravitational force. This is very important. Please pay attention. Gravitational force. Gravitational force has to do with the force of attraction. Force of attraction between all masses in the universe. Between all masses in the universe. So you see, this gravitational force we're talking about here, it acts between all objects with mass. As far as that object has a mass, gravitational force must act on it. Have you asked yourself the popular saying that what goes up must surely comes down? It's just because of what? This gravitational force. Also, you see that the earth will keep on pulling an object downwards. For instance, sometimes you can go to pick up a star apple. You'll be under a star apple before you know it, the star apple will fall to the ground. Why? It's because of what? Gravitational force. All right, so let's go ahead and look at another type of basic force, the one we call electromagnetic force. Electromagnetic force. Electromagnetic force. So this is the force that acts between charged particles. Charged particles. So the force that acts between charged particles. Like here you can have the electric and magnetic interaction, interactions. So this magnetic force also, it acts between charged particles. Like we have the attraction. Okay, let's look at that. Like we have the attraction between proton. Please pay attention. Between proton and electron, not proton and neutron. No, proton and what? Electron. Proton and electron. The attraction between proton and what? Electron. Why? Because you know that proton is positively charged and electron is what? Negatively charged. So the attraction between these two particles. You also have sometimes you can still see a magnet sticking to a refrigerator. So these are electromagnetic what? Forces in display. Okay, let's quickly move to the third one, what we call the strong nuclear forces. The strong nuclear force. Yeah, strong nuclear force. So this is the force that holds protons, protons and neutrons together. Together. And who can tell me where it is? Inside the atomic nucleus. Is that understood now? Inside the atomic nucleus. Inside the atomic nucleus. Of course, you know that proton and electron are found in the atomic nucleus. So when you are talking about this strong nuclear force, it is the force that holds proton and neutron together inside the atomic nucleus. Remember that it is this force that is responsible in keeping the nucleus of an atom from breaking apart. Yes, because without this strong nuclear force, you see that proton will split and neutron will do what? Will split. Because there is a lot of fight in the nucleus of an atom. For instance, let me show you what I mean by that. This is the nucleus of an atom, that you have much of protons and you have neutrons. Remember that when you have one or two protons, there will be a force of repulsion. I hope I'm teaching you physics right now. There will be a what? A force of repulsion. So this nuclear force, this strong nuclear force, we hold this proton and neutron there, fixed in the nucleus. It will prevent them from, from breaking apart. Thank God for the neutron there, which acts as what? Which is responsible in doing what? In keeping what? In making the force of repulsion there, in making it to be moderate. Is that understood now? In making it to what? To be moderate. Okay, let's go ahead and look at um the fourth one, which is the weak nuclear force, which is the weak nuclear force. The weak nuclear force. Now, this weak nuclear force is the force responsible, is the force responsible for radioactive, decay. for the radioactive decay and nuclear fusion reaction. So this weak nuclear force, it acts between subatomic particles such like beta decay. So, and it is responsible, it is the beta decay is the process that changes neutrino into a proton in radioactive what decay. So you find weak nuclear force in radioactive disintegration or radioactive decay. Okay, let's look at charge. Let's look at the charge value of some of these particles. Let's start with electron. One electron will give us negative 1.6 times 10 to the power negative 19 coulombs. So this is called coulombs. One proton will give us positive, please, positive, is that okay? Positive 1.6, the same value with electron, but different sign, times 10 to the power negative 19 coulombs. Then what about one neutron? What's the value? Can you guess? It is what is zero because it has no charge. It's zero. Okay, let's quickly look at an atom. That is model of an atom. I have it model of atom. Let's look at model of atom. Now, please note the whole universe is made up of atom. The whole universe is made up of what? Atom. An atom is the smallest. Atom is what? Is the smallest unit of matter. The smallest unit of matter which retains the property of an element Now there was a very famous physicist named Richard Feynman. Now they asked him the following question: if you could type a letter to an alien species telling them something about what we understand about the universe, but it was a Twitter kind of message where you could only send one sentence, what would it be? So he answered, Richard Feynman answered, he said, let's look at what he said. He said, stuff is made of atoms. He answered that what? Stuff is made of atoms. This is a kind of Twitter what message. Stuff made of atoms. Okay, let's look at the model of an atom. Let's see how it looks like. Okay, let's look at this. Model of an atom. Model of an atom. Model of an atom. Now, this atom is made up of the first shell. So this is the electron shell. This electron. So you denote it with what? Negative elementary charge. And we have this dense particle inside called the nucleus. The nucleus. This is electron. And this nucleus, inside the nucleus, we have positive charge particle called the proton. Called the proton. So you can represent that piece of superscript word positive. And you also have the neutral charge, that's the zero charge, called the neutron. So you can denote that with N superscript 0, neutron. So that is to say that a model of an atom, you have what? The electron, which is revolving around this nucleus, which is always negatively charged, and a dense part called the nucleus, which contains the proton and the neutron. And please, we all are aware that circular motion tells us that there must be a force that is keeping things moving in a circular path. This is a circular path. This electron is what is moving around this nucleus in this circular path. So according to circular motion, which tells us that there must be a force that is keeping things moving in a circle. Just like the earth moving around the sun. The earth moving around the sun, then the force that is responsible in keeping it there is the force of gravity. So in this atom here now, the force that kept this electron revolving around this nucleus is what we call the electromagnetic force. Electromagnetic force. That is wonderful. Okay, now let's go ahead and explain this part of model of an atom. Let's start with proton. Let's start with proton. Yeah, proton. So we use P superscript positive sign. Now, this proton is positively charged. Look at them here inside the nucleus. So they are what? Positively charged, and they are found inside what? The nucleus, at the center of the atom. Now, when the number of proton, this proton here, the number of this proton here is equal to the atomic number, which is what? Which identifies this element. It is this number of proton that help us to identify this element, and it is equal to the atomic number. Let's go ahead. Let's look at this. Let's look at the second one, the neutron. Now, these are the neutrons. This neutron, they have no charge. Therefore, you can say that they are neutral. And they are also found inside the nucleus, along with what? Along with proton. Along with what? With proton. Now, the function of this nucleus here is to help stabilize the nucleus. It helps does what? It helps to stabilize this nucleus. How? By reducing the repulsion between this proton. These protons here, they are fighting because they are the same charge. They are like charge. So there is enormous repulsive force inside this nucleus. So, but the function of this neutron here is to help stabilize what? This nucleus by reducing the repulsion between these protons. I hope that is understood. Good. So let's go ahead and look at electron. Now, this is the electron. Electron is what is always it's negatively charged, and moves around. It moves around this nucleus in energy level or in shells. It moves around this nucleus in energy what level or shell. That means you can still have another electron this way. So it moves in what? In energy what level or shell. Now, the number of electron equals the number of proton in a neutral atom. So for you to have a neutral atom here, there must be an equal number of proton and what equal number of electron. Let me illustrate that and show you so that we can go ahead and okay, let's look at that. Let's start with the first one, neutral atom. Let's look at neutral atom. Remember, we have neutral atom, positively charged atom, and negatively charged atom. But let's look at neutral atom. Now, in neutral atom, number of electron must be equal to number of proton. Let's illustrate that. Let's say, for instance, this is a model of an atom. And let's assume we have 3 electrons, 3 electrons here. And for us to have a neutral atom, we must have an equal number of proton here. Irrespective of the number of neutron, it doesn't matter. But what we are looking at here is the ones that have charges. Proton has charge, electron has charge. That's the one we are considering. We are not considering neutron that is chargeless. So here, this one proton here will cancel one electron. They will attract and cancel out. This one proton here will attract this one electron and cancel out. This other proton here will attract this other electron here and cancel out. So therefore, you have that the net charge is what? Is neutral. Oh my, that's wonderful. Is what? Is neutral or is zero. So this is for neutral atom. Let's also look at what happens for positively charged atom. Let's look at positive charged atom or positive charged atom. So when we're talking about positive charged atom, the number of electron must be less than number of proton. The number of electron must be less than the number of proton. Let's illustrate that using diagram. Also, let's look at a simple model of an atom. Now, let's assume we have 2 electrons revolving around the nucleus, and we have 3 or 4 protons. Now, one of the protons will cancel one of the electrons. They will attract and cancel out. Then one proton will also cancel out with the remaining electron. So we are not left with positive charge. So here, the net charge is what? Is positive. Hence, positive charge atom. I hope that is well understood. So let's quickly look at the negatively charged atom. Negatively charged atom or negative charged atom. For you to have a negative charged atom, Number of electron must be greater than number of proton. Let's illustrate that. We also have our simple model of an atom. We have that is the electron and the nucleus that contains the proton. Let's assume we have two protons here in the nucleus. Then we have up to 3 or 4 electrons. Okay, we can just make it 3 for simplicity's sake. So one of these proton will attract one of these electron and cancel out. One of these proton will attract one of these electron and cancel out. So we are left with electron. So we are left with what? Electron. Hence, negatively charged what? Atom. Hence, we have what? Negatively charged electron. That's negative charge atom. So we have that as negatively charged atom. Let's also look at, take 1 or 2 examples. Let's just use lithium to also further buttress our point. Let's look at lithium, positive lithium. Now, lithium has 3 protons, 2 electrons, 4 neutrons. Remember I told you we don't consider neutron. We only look at proton and electron. Now, this is called positive lithium here because we have the number of proton that is greater than the number of electron. Is that understood? So whenever the number of proton is bigger than the number of electron, that means you have positive atom or positive element. Okay. So here, number of proton here is greater than number of electron. So therefore, we have what we call positive net charge. Positive what? Net charge. I hope you are following. Okay. Let me give you this for you to do. Okay, what if we have 4 electrons? 4 electrons and 3 protons and possibly 4 neutrons. Now, what will be our lithium? Is it negatively charged or positively charged or neutral? Definitely, since the number of electrons here is bigger than the number of protons, that is to say that this lithium is what? Is negatively charged. Then what if we have 3 protons, 3 electrons, and possibly 4 neutrons? So which lithium are we going to have? Definitely we are going to have what? Neutral lithium. Why? Because we have 3 protons and we have what? 3 electrons. When they attract, they will cancel out and it will be left with no charge. So that means here, proton is equals to electron. Hence, we have what? 0 net charge. 0 net charge. So remember for this, here, electron is greater than the proton. That is, we have what? Negative what? We have what? Negative net charge. Negative net charge. Okay, that's well understood, right? Good. Now we have what we call plastic rods. Plastic rods and four are particularly good for demonstrating electrostatics. And what is this electrostatics? Which is the interaction between electric charges that are at rest. Now, Benjamin Franklin was the one that suggested that we call these two kinds of charges positive and negative charges. Positive and negative charges. And negative charges. Now, let's look at rule for charges. Rule for charges. Let's look at rule for charges. Now we have number one, like charges. Like charges does what? Like charges, they repel. They repel each other. Let's take, for instance, we have a positive charge here. And we also have a positive charge here. Because they are the same charge, they are going to repel each other. They're going to run away from each other. They will not like to be with each other. No, they will run away. One will go to America, one will go to Nigeria. They will run away from each other because they are the same charge, otherwise called like charge. Okay, let's look at the second one, unlike charges. Unlike charges. What does it do? They attract. Unlike charges, attract each other. Okay, let's look at this also. We have this. We have positive charge and we have negative charge. You see, they are different charges, so they are going to run to each other. Yes, they are going to be attracted to each other. So you see, we have what? Force of what? Of attraction. Force of what? Attraction. I hope there is no question here. So we have this a normal rule for charges that we always sing like song. Like charges repel, unlike charges attract. That's good. So let's quickly move into types of charging. There are so many ways uh, we can charge objects. Let's look at that. Types of charging. So the first one we're going to look at is what? Charging by friction. Charging by friction. That's the first one we're going to look at. Charging by friction. Now, when you have glass rods, we are going to demonstrate this. When you have glass rods and silk, when you have glass rod and silk, what happens? Okay, let's look at this now. We have glass rods. These are glass rods. This is glass rods. And let's use this as our silk. Let's use this as our silk. So when you rub this glass rod by this silk, you will see that energy will be created as a result of friction. You know that, for instance, now if you rub your two palms, you will feel hot, you will feel heat because what? Friction. That has to do with what? Two body in contact to each other. So this is a type of a contact force. Is that understood now? So when you rub this glass rod by this silk, energy will be created, which is as a result of what? Friction. So when that happens, electron or charge will be given off by the rod to the silk. That is to say that electron here in this glass rod is going to move to this silk. Is that understood now? It's going to move to this silk. And the total number of electrons that this glass rod lost will be equal to the total number of electrons gained by this silk, according to the law of conservation of charge. So when that happens, this glass rod will become positively charged and this silk will become negatively charged. Let us illustrate that to address our point. Okay, look at this now. Remember that initially this glass rod is neutral. It is neutral because the number of proton equals the number of electron. That's why it is neutral. I hope you are fully paying attention. So this is what a neutral glass rod now. So this is what neutral, neutral glass rod, and it is neutral because the number of proton, we have how many number of proton here? 1, 2. Electron 1, 2. So they are equal, and that makes this glass rod what? Neutral. Okay. Now let's go ahead and look at silk. The same way with silk. Silk also has what? The same number of what? Proton with the same number of what? Of electron. Let's assume it has 3 protons, which it will also have what? 3 electrons to make it what? Neutral. So this is also what? Neutral. Of course, you by now you know what I mean by neutral. Neutral. 1, 2, 3. 3 proton, 1, 2, 3, 3 electrons. So it cancels out. It attracts and cancels. So it makes that silk what? Neutral. Is that understood now? Good. Okay, now when you rub this glass rod by this silk, what happens? Electron will leave this glass rod and enter in this what? Silk. Remember, and I keep telling you, just like in my previous class, I keep telling that the one that always moves is what? Is the electron. Is the electron that is the electron is the one that is free to move. The proton here, the positive charge doesn't move. What moves is what? Is the electron. That's the one that is mobile. Yes, it's mobile. So this electron will leave this glass rod and enters what? This silk. Okay, let's look at that now. Okay. Now, if this electron leaves this glass rod and enters here, that means the glass rod we now have will be what? Will be positive. The positive will remain. While the silk we now have excess of electron. That's negative charge. Remember, we have what? Proton 1, 2, 3. Then the electron will now be 5. 1, 2, 3, 4, 5. You see. So when this proton here now cancels with this cancels with this cancels with this. So we are still left with 2 electrons. So the net charge here is what? Is negative. So net charge here is what? Is negative. I hope this illustration is very clear for you. It's negative. Why here for this glass rod is what? Is positive. So this charging by friction will leave this glass rod positive at the end of the day, while leaving this silk negatively charged at the end of the day. I hope that is well understood. I hope that is well understood. Now, let's go ahead and look at another way of charging called by conduction. Let's look at charging by conduction. Here, charging by conduction. Let's look at that. Charging by conduction. Now, let me draw a diagram to illustrate this. Let me quickly draw a diagram to illustrate this. Illustrate this by charging by conduction. Let's look at this. We have you can call it a record stand. Have a stand. Then we have a metal ball attached by means of thread. By means of thread. This is a metal ball. This is a metal ball. And this is thread. This also is a thread. This is a thread. Good. And we have a copper thread. A copper thread is being attached on this metal ball and it's being held by this thread. And we have a charged plastic rod. We have a charged plastic rod, and this plastic rod is negatively charged. It's negatively charged. So we have negative charged plastic rod. So we have negative charged plastic rod. This is a charged plastic rod. Now remember that this metal ball is neutral. Why is it neutral? It is neutral because the number of proton equals the number of what? Electron here is neutral. It's a neutral metal ball. So when you connect this copper thread, this is a copper thread, okay? This is a copper thread. Remember that copper thread is what? It's a good conductor. So when you touch this copper thread to this charged plastic rod that is negatively charged, what happens? Charges will flow from this copper thread to the metal ball. And which charge is flowing is the electron that is flowing, this negatively charged that is flowing, this metal ball. So when that happens, we will now have excess electron in this metal ball. Is that understood now? We have what? Excess electron in this metal ball. So you see, it will now leave this metal ball negatively charged. Let me illustrate that so that you understand what I'm saying. Now, initially, this metal ball is neutral. For instance, it has positive, negative, negative. So it's neutral. So when you now connect this copper thread, when you now connect this copper thread to this negatively charged plastic rod, 1, 2, 3, plastic rod. So what happens is that this electron, the one that is mobile, will move through this copper thread and enters here. So we now have another 3 electrons inside the metal ball. 1, 2, 3. So you see, we now have more electron than proton. So what will now be? So it will now be what? Negative net charge. Negative what? Net charge. So you see, this metal ball will now be what? Negatively what? Charged. I hope I'm teaching you physics. That is wonderful. Now, let me also show you something again. Let me try to illustrate this unlike poles repel, unlike poles attract, while like poles repel. Let's start with what? With like poles. Let's also assume we have this setup. This is a metal ball, and this metal ball is what? It's negatively charged. This is a metal ball. It's negatively charged. This is a metal ball, negatively charged. Then when you bring a negatively charged plastic rod, one, two, three, plastic rod, that's plastic rod, charged plastic rod. When you bring it close to this metal ball, you will see that this metal ball will do what? Will run away from the plastic rod. Therefore, you will not see that the diagram will not be like this. The metal ball is what? Is running away from the plastic rod. So it will do what? It will run away. So you see, the force will do what? Will move this way. Force of repulsion. It will repel it. Okay, how about you bring a positively charged rod to it? Okay, let's take for instance now. Let's modify this. Let's quickly modify this. Here now we now have this setup. We have this setup. Okay. Okay, let's start from here. Let's assume here. We now have this setup. This is negative, and we now have here as positive. Positive what? Plastic rod. You will see that it will attract each other. So the diagram will not be like this now. You will see that the ball will now move towards the plastic what? Rod. The positively charged plastic rod. To show the force of what? Attraction. To show the force of what? Of attraction. To show the force of what? Attraction. This demonstrates the rule for charges. Like poles repel, unlike poles attract. Okay, let's look at that. Look at application. Let's look at application of electric charge. And we just call it a day after that. Then in part two, we look at some calculation involving electric charge. So let's look at application. Applications of electric charge. Of electric charge. Applications of electric charge. We have so many applications of electric charge, but let's look at the few. Then I will give you assignment to check out the remaining. Then we have photocopier, photocopiers, and laser printers. And laser printers. We have also the lightning and thunder formation. And thunder formation. These are applications of electric charge. Also have charging of balloon or comb by rubbing. By rubbing. These are experiments that we can do in the laboratory and so on and so forth. So we call it a day. So in our next class, we are going to look at some calculation involving electric charge in part two of this lesson. So do well to like and subscribe. And if you have any question, please put it down on the comment section. See you in the next class. Thank you.